Vienna Center for Logic and Algorithm. As our first speaker, it's really a pleasure to have with us not only a very prominent scientist, but also the one who initiated the Women in Logic initiative, Valeria de Paiva. So maybe Josephine can introduce her.
Yes, of course. Thank you, Agatha. Yes, it's my pleasure to introduce Valeria de Paiva to you. Valeria is a mathematician, logician, and AI scientist working on natural language processing, logical inference, and all kinds of semantics, specifically dialectica categories. Currently, she is at the Topos Institute in Berkeley, and before that, she worked at top industry natural language processing labs, including Samsung Research America, Nuance, Team, and for many years at Xerox PARC. Before that, she was a professor at the University of Birmingham in the UK. And additionally, she is very keen on making sure that women are not too shortchanged in their professional life. For that, she maintains the Women in Logic website, Facebook group, the blog, and she helps the ACMW scholarship program. And she starts, of course, the international workshop of Women in Logic, which is now going for its 7th year. If you, during the talk, have any questions, please collect them in the chat, then we will kind of go over them afterwards. And now the floor is yours, Valeria.
Oh, thank you so much, Josephine. Thank you so much, Agatha. It's wonderful to be here with you guys. Thank you, Andrea, for helping with everything behind the scenes.
You're welcome.
Thank you. So what I want to talk to you about today is a little bit more about what Women in Logic is. And I'm so pleased that we now have Women in Logic online, that series. That's fantastic. And then because we normally, in the Women in Logic kind of collective and all the things that we do, we like to say things not simply about the difficulties that we have as women in STEM, women in logic or computer science or mathematics, but we also want normally to talk about our own work. So talking about my own more recent work, stuff that Josephine did not mention. Thank you very much for the lovely introduction. But I want to talk about network mathematics, which is something that I started doing recently and that is still very much at the beginning. So more thanks, because it's important to put a name to the faces. So that's Agatha and Josephine. And as I was saying, I want to talk about two different things. I want to talk about Women in Logic, what, why, and how. And then I want to talk about network mathematics. And when I talk about network mathematics, I want to talk about some research prototypes that have some funny names like Parmesan, Math Annotator, and Math Gloss. And then I want to talk about, as I was saying, this is just a beginning of a project, so I want to talk about what's next. So first things first, Women in Logic is a collective, meaning that we don't try to have very hierarchical structure to Women in Logic, because all of us have lots and lots of work in our lives. Apart from our 9-to-5 work, we normally have houses, kids, parents, lots of people to look after, and lots of administration, lots of teaching, lots of mentoring. And hence, we don't want to spend all our time thinking about the difficulties of being a woman in logic or a woman in computing or a woman in mathematics. But I think we need to do some of it. So this is a nice picture that someone gave me last year of 500 important women. And, this is bittersweet, right? Because in one hand, it's kind of good to have many more of us doing stuff, but it is a little bit sad that no one would have ever thought of doing 500 men in anything, right? And for women, we still have to do these things because we actually don't know much about our predecessors, the people who have come before us. But as I was saying, we are very non-hierarchical. We're trying to get more organized, always trying to get more organized, which I think is another thing that most of us women are always feeling that we need to do more to be more productive, more organized, to do more things. And the thing that we have been managing to do consistently is the Women in Logic workshops. So actually, Josephine, we're slightly wrong with this year. 2024 is the 8th Women in Logic, because we started in 2017. And these are pictures. Of course, you know, we had 2 bad years of online only because of the pandemic. And this one was not exactly online only, but was still a little bit problematic. And now we are back at having things in presence, kind of seeing each other much more. So as I was saying, the Women in Logic workshop is our flagship event. This is our 8th year. It's going to happen in Tallinn, Estonia, together with LIX and FSCD. And the first one happened in Reykjavik, Iceland, in 2017. And after that, we had Oxford in 2018, Vancouver, Canada in 2019, Paris and Rome online, then Haifa in Israel in 2022. And 2023, we had Rome and Italy, this time associated with FSCD. The others were either FLOC, which is the Federated Logic Conference, or LIX. And one of the things that when I kind of start saying to people this business, that I find it very important to make sure that women are not too shortchanged in their careers. When I kind of start talking to people about that, they always kind of come back and say, well, but why do you need to do that? Why do you have Women in Logic? And I have a collection of reasons for that, and I wanted to kind of discuss them with you bit by bit. So the first one is some sort of worldly reasons. And, you know, I actually sometimes have fun finding horrible statistics to show everyone else. So do you know that according to the United Nations Women, and I give you the link there, it will take 286 years to achieve full gender equality in the world. It's bad, right? We'll all be dead by then. Kind of our kids will be dead. Our grandkids will be dead. It's not good. And of course, this is assuming that things carry on the way they have been doing since the beginning of the 20th century, since the 1911, when, say, Women's International Day was established or something like that. So, since the reason for Women's International Day happened, the famous strike in 1911, kind of asking for things that we're still asking now, right? More than 100 years later, we're still asking for legislation that protects women, right to vote, right to be voted, right to own property, right to employ people, to be employed, not to be murdered, as it happens in several places. So things are not as good as they could be. In terms kind of money, the gender gap is very real, but you kind of keep hearing people saying the gender gap doesn't exist. Some women's organizations kind of pay attention and try to make sure that people know that will take, according to the World Economic Fund, 132 years to achieve equality in terms of payment. And the thing is, this kind of calculations are predictive, right? So you kind of see how things are going and predict how long it will take to get where you want to get. And of course, because of the pandemic, we actually kind of went back quite a bit. In 2020, the same guys, the WEF, predicted 100 years to close the gender gap. Now they're predicting 132. So not only it's taking too long, it's also kind of going backwards in some sense. Not all the time. Lots of things are getting better. It's not to despair, but things are not very good. And of course, one of the places where we are making huge progress is education. Education is getting closer to equality, but the majority of children who are out of school are still girls. And as I was saying, I give you some more, I gave you some pointers there, but I have a few more disturbing things to discuss. So for instance, still talking about the world at large, you might think, because, if you have been checking these things in any case, you might think that that Europe is the best place. And yes, it's one of the best places, but in particular, if you look at countries, the 10 most gender egalitarian countries, 8 of them are in Europe. But according to, again, the World Economic Forum, they think that Latin America and the Caribbean will be the place that's more likely to close the gender gap. And it will take 53 years if in the good sort of situations, thinking of good cases. And Europe 67, North America 95, Sub-Saharan 102. These calculations, as I was saying, are very difficult to make. I cannot vouch for them myself. I'm a mathematician who does not a statistician, and I don't work on the problems of women in the world. I'm a logician, like most of you, I believe. But logicians can look at different people's studies and compare them, and that's what I'm kind of trying to do a little bit for you now. Whoops. Sorry, something horrible happening here. Let me get, that's what we saw. That looks better. So that's where we were. So now kind of getting closer to us, right? Because you might say, oh, Valeria, you're talking about the whole of the world and salaries for the whole of the world and stuff like that. Let's get closer to us. The labor markets of the future are us, right? They are STEM occupations. And women already make up almost half of the total employment across non-STEM occupations, but only 29.2% of the STEM workers. Now I'm again giving data from this World Economic Forum. And as we were saying a minute ago, education is getting better. So female STEM graduates are entering STEM employment with with every cohort. But there's no retention. And this is a serious problem, meaning women don't stay. They graduate from good places, in places that they could put their skills to use, but by and large, it doesn't happen. It is famous leaking pipeline that starts in kind of high school, but carries on. And in particular, there is the famous glass ceiling, meaning that women don't get to be bosses, they don't get to be managers, they don't get to be in leadership roles. And more worrying yet is this business that women working in AI, which kind of even, as we are seeing in a minute, it's one of the places that's growing most at the moment. They grew, the women working in AI are approximately 30% now, which is 4% higher than it was in 2016. So, you can say at least you're going up. It's little, but we're going up. But if you compare with the total number of workers in the same time, they increased 6 times. So we're losing proportionally all the time. So getting, again, closer to logic and mathematics and computer science, theoretical computer science, which is the kind of stuff that I do, and I expect most of you do too. There are kind of more specific studies, but some of them are old. This one comes from 2015. It's called Solving the Equation, the Variables for Women's Success in Engineering and Computing. And to many of my friends in Will, I have always showed this graph, but mostly I kind of showed the graph from 1990, because that's kind of when I kind of started paying attention to the world and stuff. And as you can see, the other thing that people normally say to us is that things, you have to give time to time. Things are getting better, Valeria. You just have to have more patience because things are getting better. Well, from when I started thinking about life and everything in the 1990s, the number of women employed in the greenest computer and mathematical occupations went down from 35% to 26%. And so, this is data from the United States. It's not, I mean, there might be some variations and stuff, but at least in terms of personal anecdotes, talking to friends and stuff, when I first started university, there were 5 of us in a class in a cohort of 40 people. And some of my friends who stayed in Brazil and kind of teach there tell me that nowadays, sometimes they have classes that have not a single woman. So, okay, these classes are engineering and computing and mathematics and physics and chemistry. They are kind of a generic STEM education, as they call it. They are science and technology education. But what I'm saying is simply that the numbers that I can see from personal anecdotes actually tally with what the researchers from the American Association of University Women, the AAUW, produced. But okay, their numbers are only until 2015. I'm not going to even read that, but it's just to show that even the U.S. government does go into the public and tell them that that the future of the whole world is in computer and mathematical occupations, and hence women should be going there. But we have this leaking pipelines altogether that need to be addressed. So kind of, as you can see, we went from the world to kind of slightly less the United States, and then now kind of a little bit more about computing and mathematics and engineering. And now we kind of get into the community that I think most of us belong to, that's more logic in computer science or logic in philosophy or logic in AI. And in 2013, Orna Kupferman, who was the first woman to chair LIX, had this dismaying news. Because you see, up to 2013, I was thinking, okay, now things are bad, things are not going so good for women, but at least in our little corner of the world, things are good, right? I mean, I can do my work, I can talk to my friends, and I can submit papers, but when Orna came up with these numbers, right, things like invited speakers, almost none, clean awards ever, 18 men, 1 woman, typical PC, 30 men, 4 women. And the fact that the conference has been going since 1986, and that was in 2013, and she was the first woman PC chair, and all the other things like the Fields medalists and Nobel Prizes and everything. We see that we do have it's not okay in our corner of the world. It's not okay in our backyard. It's bad almost everywhere. So In 2016, there was a celebration of 30 years of lakes in New York, and I was invited to kind of say a few words about, since I've been going there for donkey's years. And I kind of gave an impromptu talk, and I said, oh, I'll talk, but you might not like it very much, what I have to say about the lack of women in our community. Shankar, who was the chair at that stage, said, oh, no, it would be fun. Go talk. And, was kind of very much last minute, because he invited me to over lunch, and I had to talk at 4 o'clock or something like that at the end of the afternoon session or something. And if you remember, 2016 was also the year of Me Too movement. So kind of, I think, it caused a bit of a stir in the meeting. And then in there, I said, okay, let's do something. Let's do something easy, but something. It doesn't have to be revolutionary, but we need to do something. And so we started doing the Women in Logic workshop. So what we thought to ourselves, and that was not only me, lots of friends kind of were around, and we kind of discussed the situation and said, what can we do? And we said, okay, kind of a workshop is easy. We are here in any case. We have work to discuss with each other. We kind of, let's organize a one-day workshop to celebrate women and to give support to other women. And let's talk to other women about our work. And so the system kind of started getting into place, and we started having 2 invited speakers and an open call for contributed short talks. We collocated with, as I was mentioning before, with different other conferences. The point of that is that, having a small conference completely on your own is too much work. You have to do all the finding rooms, doing registrations and stuff like that. So we always collocated with a bigger conference. And so far, we have 8 years of Women in Logical. We will have 8 years in July, in 8th of July in Estonia. But we had a huge growth during the pandemic because things could be done online. But there are lots of new challenges for us and for other conferences. There's all this difficulty with price of conferences being too high. There's the problems with climate change and people not being able to go places. There's a collection of problems that we are trying to address. And I think Women in Logic Online is a great way of addressing some of these problems. I'm really very happy that we're doing it now. So at the moment, we have a steering committee that's kind of these 9 people. So that's Agatha, Amy, Alexandra, Brigitta, Vrinek, Sandra Alves, Sandra Kiefer, Sonia, and Sarah Okerman. And we are trying to increase our activism, and we kind of trying to get more than just the Women in Logic workshop. We want to have other initiatives. But our main thing is still the Women in Logic workshop, and the Will workshop organizers in 2024 are Daniele Nantes, Tefla Prince, and Elaine Pimentel. And they're wonderful. And, all the organizers we had so far have been wonderful. All the invited speakers have been great. And the PC members and PC organization has been fantastic. So at the moment, you can find us in our blog, which is called Women in Logic, in our Facebook group, which has more than 600 people. We have lots of data collection because lots of people keep saying to us, and the problem is I cannot find women to invite to talk in my conferences. So that's why they say they have manels, this panels that only have men talking about things, including reproductive rights and issues that I would have thought needed a woman in. But so we have a big fight against the manels, and And we are losing that one because they carry on doing them. So you have data collection and directories of women in different areas so that people cannot use that as an excuse. We have Twitter and now X, mailing lists, Slack. We have lots of interesting initiatives, but we need more help. We need more people joining up on this and trying to change this business of 286 years until equality, or kind of the other very bad statistics that I kind of keep in my hand, and that's another one from the UN, is that a woman earns 51 cents for each dollar a man earns in general in the whole wide world. So, I mean, our work's cut out for us. There's an awful lot to do, and I think we have to carry on doing. But now that was half of my talk. I want now to go and talk about more exciting things that are a little bit more, I find more optimistic. But, you know, it's still fight. It's still not completely optimistic, because what I want to talk to you about now, there's a raised hand. How do you want to do that, Josephine?
Yeah, I was actually first thinking to do the raise hand like after the talk, but maybe since now we have kind of a natural break between two topics, we can already discuss the question. What do you think, Valeria?
Sure, makes sense. Yes, that's good.
Okay, then I see a question of Sarah Ayhan. I think I can. Sorry, I think Andrea is now the main host, so she has to unmute you. Andrea, are you still?
Yeah, okay, I will allow Sarah to talk.
Perfect.
Let's see.
Okay, Sarah, I think you should be able to talk now, or to be able to unmute yourself.
In alternative, we can read the question.
Yeah, but I think this is a different question than the person in the chat, because there's a different last name. But we can also do the question in the chat first.
Yes, I think it's easier.
Yeah. Okay. Yeah, so in the question and answer, Sarah K says that it would be really interesting to see an update of the Courbet and Hill statistics.
So would I. Who wouldn't, right? But you know, I have looked in their website, on the website of the AAUW, and they haven't got us a new update. So someone else has to do it.
Great. I see that the other Sarah mistakenly raised her hand, so we can move on to the next
We can
part.
proceed with the second part of the talk now.
Oh,
Yeah.
cool. Let's go for the second part then. So it's another bit of a fight, but it's a different fight now. I think, you know, as we were kind of discussing at the beginning, logicians are in a very interesting situation, because logicians can be philosophers, can be mathematicians, can be computer scientists, can be AI scientists, can be all sorts of different careers as such, and all of these careers, including the other things that I'm not paying much attention to because I don't like them so much, like chemistry. But you know, the things, all of these things, including the chemists and the physicists and the biologists, everyone needs mathematics, right? And nowadays, with the problems with AI being the way they are, some people, some important and powerful people, like the CEO of NVIDIA, have been saying that that you don't need to program anymore because you can just talk to your computer. And that is a lie, a very clear lie. And as this tweet in shows, you know, as the guy says, Elon Musk and Sam Altman, the CEO of OpenAI, may not agree on much of late, but they do agree that AI is built on strong math foundations, including algebra and calculus, and certainly including logic, even if they didn't mention it. And hence, it looks like we do need better math for society as a whole, and particularly for AI. And one of the things that when the pandemic struck and we kind of all stuck home and stuff, some of us decided to create the Topos Institute, which is a different sort of startup. It's a startup that's a non-profit startup, and I should have put here our main motto is make sure that the sophisticated and new sciences that we develop are useful for the benefit of all of us, for the benefit of society. And so when I kind of joined, or when I kind of was part of this people trying to think about getting the Topos Institute off the ground, we kind of thought that one of the things that we could do is actually try to use the tools of AI to improve the accessibility of mathematics to everyone else. And I mean, of course, you do want to do it in all levels of scholarity. You want to do it for kindergartens, for elementary school, high school, undergrad maths, and postgrad maths, and research math if you want, but you want to do it kind of using newer tools that the AI systems as a whole have produced for us. So I was thinking in 2020 that would be good to kind of organize, to produce infrastructure for organizing and communicating results in mathematics. Because everyone knows, I mean, I'm going to use mathematics, but you can think science, or you can think STEM, whatever takes your fancy, whatever one you prefer, because this is a graph showing the growth of the mathematics literature from 1940 to 2017, and it has an exponential growth. But I know of similar graphs for chemistry, material sciences, physics, and everyone else. And all of us need more infrastructure for organizing and communicating results. Because now we're talking about as researchers ourselves. So what I'm saying is that we wanted something, when I started in Topos, we wanted something that was useful for society, but also useful for us logicians and category theorists and mathematicians in general. So we wanted to avoid wasted search time. We wanted to avoid duplication of research, missed connections between fields. And there's a very telling anecdote from Quanta magazine in November of 2019. I've forgotten to remove one extra zero and an extra 9. But there's a very interesting anecdote there where they were saying that some physicists discovered a very easy and simple equation in linear algebra. And linear algebra is one of the most established bits of the mathematics curriculum. Everyone knows, I presume, has done at least one course on linear algebra. But the physicists kind of said, oh, this is so obvious, it should be in the textbooks, and they couldn't find it. So they sent a message to Terence Tao, the Mozart of mathematics, as they call him, and because he had done some work on something similar, and he said, no, never heard of this. And he said that he first thought was false, couldn't be true, otherwise we would know it. But then discovered that he couldn't find it in any of the literature. And he wrote a paper, and the physicist wrote another paper. And once the paper was published, 36 people came up and said, "Oh, but I proved that in such and such and such and such and such and such." So what the anecdote is trying to tell you is that we have too much wasted search time, too much duplication of research, and too many missed connections between fields. And we needed to get, we should try to get these things in a better state. So we kind of want to have AI trained to read science papers, and so that they can predict future discoveries and stuff like that. So we want to do, and there are some of this stuff already happening, albeit in a very small scale, much smaller scale than you'd expect people to be doing it. So we now want to do the same for the math literature, and that is the project Network Mathematics that gives a name to this part of the talk. So the question is, how? How do we do that? One of the ideas is that we should make use of the incredibly fast improving NLP tools, in particular things like generative AI and transformers and all this new stuff that has been developed since around 2017, 2018. And our idea was to extract math concepts from texts, because there's an awful lot of mathematical text on the web. But you know, the mathematical text that's on the web is not very processable from the AI point of view, because we have all this stuff in LaTeX and in PDFs, and that makes this this literature much harder to deal with than the literature, I mean, the stuff that people in AI normally deals with, which is kind of newspaper text. So one of the ideas is to kind of extract math concepts from text and link it to ontologies and build a math knowledge graph. And we hope that will also be useful for formalization, improve assistance, and tier improvers. But this is all kind of things that we want to have. Now I want to talk a little bit about how we go about it. So I don't know if you guys do the same, but whenever I read some mathematics that I'm not familiar with, and I do read an awful lot of mathematics that I'm not familiar with, I normally go around thinking about these little blobs in red there, but in my head only, saying, well, maybe I need to know what a torsor is. Maybe I need to know what an inverse semigroup is. Maybe I even need to remind myself what a group is, and definitely check what the topos is and a category of torsors and stuff like that. So what we would like, one of the first things that would help with this business of making mathematics more accessible to others would be to have a system, an AI system that would kind of read a text, give you the concepts that are there, and kind of index it for you automatically and on the fly. It's something that we always thought we would have since hypergraph, right? Since this early 1990s. But for several reasons, we don't have that quite yet. What we do have is kind of very smaller systems based on those ideas. And I wanted to talk to you about 3 such smaller systems. The first one is called Parmesan. And here, you know, you don't have to read that. It's just so that later on, if you want to look at it, you have the proper reference. There's another one called MathChat that uses more sophisticated AI tools, meaning use ChatGPT and GPT-4, and you can also read about it. And there's MathGloss, interesting, which is our attempt, and that's a project with Lucy Horowitz, who is a student in in Chicago, who is an undergrad student. I mean, the other two projects are with researchers that are more established, but Lucy is a very young one. And what we're doing is we are connecting open source electronic glossaries on the web to kind of facilitate the life of people who are trying to learn things that they don't know much about. And there are other projects that we are still starting that, but they are not written yet, so there's nothing I can point you to it. So what is this basic idea of network mathematics? The idea was always that we want to use AI and NLP tools off the shelf as much as possible. And for that, you need textual corpora. And I was trying to explain that we have loads and loads of mathematics on the web, but these are not textual corpora, meaning they are not processed so that you can get information out of it. So you need to do text retrieval and info retrieval from these things, and it's hard because of LaTeX, diagrams, equations, and all this stuff. So we thought we needed to construct corpora and find amongst the tools that the AI guys, the NLP guys have, the best ones to use for our own purposes. And so I asked myself, what linguists have for extracting math concepts? And they have several tasks, because the way AI works is that we work on specific tasks at, what you want to do eventually is understand the mathematics, but what you can do is smaller tasks like named entity recognition, which you can do, which in the case of newspaper text, it means finding Barack Obama and Paris and the UN, so kind of organizations, people, and places that appear very strongly on newspaper text or a web text in general. But as you might expect, we don't have mathematical concepts, don't have that kind of brand recognition. You have a problem that if you say ring in Google without anything else, you're going to get engagement rings or jury, but not algebra rings. And the same goes for all the other stuff. So, the named entity recognition for mathematical concepts is harder than some of the other stuff. And same thing about keyword extractions and similar things for definition extractions. But all these tasks the linguists know how to do, and we can try to use their tools. So there's no automatic term extraction system dedicated to mathematics, as far as I know. We are trying to do similar things, part of these things. But there's a collection of rule-based and neural network systems to begin with, and we use those, and we construct our first corpora. There are some other corpora for mathematics, but they are used for completely different things. And as I was saying, things here have to be for specific tasks. So, people do use problems in elementary algebra as a corpus and something like that, but they are actually trying to solve elementary school problems or something like that, whereas what we wanted was generic concepts of mathematics. In particular, we wanted generic concepts of undergrad mathematics, because we thought that was the most useful for people who are kind of trying to being vaguely digital aware and trying to move between fields. So we created, because people in the Topos Institute like category theory, we kind of started thinking, and because category theory is a organizing tool for mathematics, we started our corpora with category theory, and we have the abstracts from TAC, theory and application of categories, which hints at the second problem that we have with this stuff, which is that there's an awful lot of mathematics on the web, but lots of the mathematics on the web are under paywalls, and you have problems to get, I mean, you're going to say, oh, Valeria, but haven't you heard of the archive? And of course I have heard of the archive. And of course, the archive is a wonderful thing. But even the archive doesn't have as good a license as you might think. You have to do there's some difficulties that you have to go over. There's the problem with LaTeX that we mentioned before, but at the moment the archive is tackling it trying to make it more HTML. I don't know if you've seen it. That's one of the things that they are doing. And there's this problem that publishers kind of, the big publishers keep lots of the stuff under lock and key, and only them would be able to kind of do some of this stuff. So another problem that for later. What we can do is there's also lots of open source journals. There's lots of open source material. And so we establish ourselves completely on the open source material. And we created a few corpora to try to do this business of extracting concepts. Now, the problem we have is that checking things. So, you can produce an AI system that does extracting of mathematical concepts, but you need to prove that your system is doing what you want it to do, and checking things and evaluating things is pretty hard because you need baselines, and baselines are normally constructed by using things like Amazon Turks, so the Turks, and we don't think that mathematicians or computer scientists or logicians would accept being paid 25 cents an hour to mark things for hours on end. And so, the traditional ways of doing AI are a little bit harder for this kind of specific literature. And the only thing that we could find in previous systems was an ACL 2017 competition on scientific concepts. There's one very small golden data set, actually even paid by Elsevier in 2017, but it has no mathematics, and it's far too little, even for evaluation. If you want to see some of our problems extracting mathematical concepts from text in general, there's a little YouTube video, 6 minutes over there. So what happens then to us was to say, okay, let's try a different tackle then. Instead of trying to prove that we're extracting all and only the mathematical concepts, let's pass this task to the user. And so we created this system, this small prototype system called Parmesan. And you can go to the website and see Parmesan in action. And what Parmesan does for you is that you put a concept that you don't know in category theory in this little search box, and it will give you answers of what are the concepts in the two different knowledge bases, the NLab and Wikidata. And then it will kind of show you how this concept is used in 3 different tiers of understanding. The first one is a textbook, which is Tom Leinster's textbook, which is open source. Second one is the NLab again, because the NLab is a resource constructed by the community of category theory to explain its own concepts and problems and things that they want to do with it. So the second tier is kind of post-grad mathematics. And then a third tier is actually research mathematics, which is TAC in this case. So let me just check if I said everything that I wanted to say here. Yes, you're not linguists, you don't want to hear much about the AI checking of these things, but we actually tried all the sort of state of the art, not only in 2019, but in 2021 and 2022 to show that how bad the things were. And we actually now have a new paper coming up on that this year, 2024, in Coling LREC, which is a good conference. So we kind of and we kind of think we can do Parmesan for other areas of mathematics too, and it should be interesting, and we want to complete the undergrad mathematics to a certain extent, but we still want something more like a WordNet for mathematics. Since we have a team with 3 mathematicians, we try to use, as I was saying, more sophisticated AI tools, in this case, generative AI, which means ChatGPT and GPT-4. So we kind of have a second small prototype for that. And as usual, we need to annotate a small set to be able to evaluate what, say, ChatGPT is doing. But I'm sure you can see that that would be very helpful, and I'm getting too late, but it would be very helpful for everyone if we could make sure that a version of ChatGPT did produce the terms that you could extract from any big file, right? Because of course you want to, that would give you a way of making an automatic index, which would be useful if you were writing books. But even if you're just kind of trying to personalize your own study and you want to learn things, you could collect things that you think you should be reading and produce a personal index of this stuff with little links that would let you go back to where the definition was. So this is a little bit more complicated than we thought, and I have there's lots of decisions that one has to make here, and decisions that mathematicians should be giving their opinions on. Some of them are trivial things that linguists know how to do, like you should use plurals or not, or adjectives. If something's called a 2-categorical version, should that be a concept or not? It's a hard one. If you have things like interpolated function, interpolate, and interpolation, do you want to choose one of them? Do you want to have all 3 of them? How you go about that? It's not a total triviality. And we reckon that for this thing to work, you have to treat the math concepts as much as possible as black boxes, or red boxes, like I was showing early on. Because, what is a total obvious thing for one mathematician might be very unknown for another, and certainly for a physicist or chemist or computer scientist. So we had to kind of produce some annotation guidelines to try to get helpers to do with that. And we have a collection of experiments, which we showed in a workshop in September last year. And because it was hard to make this, to show how well ChatGPT was doing, we repurposed an annotation tool. And so here you see, if you want to see, that's how people do experiments with ChatGPT, and kind of this famous bits of prompt engineering, kind of making the prompt more and more complicated to try to extract more and more information from the large language model. And this is our small prototype. It kind of helps if we can get an annotation event happening, helps different annotators get to a consensus, a mathematical consensus of what are the important concepts. So, each person kind of has to go there and decides if they are uploading different texts or getting math concepts or something. And ChatGPT produces, from reading a sentence, produces what it thinks are the concepts in the place. And the human can say, no, that's not good, or yes, that's good, or stuff like that, and then submit the annotation. So I'm not going to go about that. So I just want to finish with MathGloss. Actually, I want to finish describing MathGloss and then saying where we want to go next. But the idea of MathGloss is, as the 2 previous ideas, this thing that there are many resources and many audiences, and we actually want to make it easier for different audiences to get to the many resources. And in particular, we want to organize the various resources that we know exist for undergrad level mathematics. And we want to perhaps use these several resources for undergrad mathematics to bridge the language gap between natural math as it's written in papers and in blog posts and everything, and formal math, now meaning mathematics done by a proof assistant or a theorem prover. And you might say, well, Valeria, aren't you going crazy? I mean, aren't these things completely different? And not totally. Let me show you. This is MathGloss. You can play with it. It contains, again, like Parmesan, it uses weak data as a kind of proto knowledge base for mathematics, and it has special corpus constructed by Lucy, as I was mentioning before, who she was very careful while doing her math degree to take notes of all the definitions that she had heard, and so she has and put it on the web to help others. So we used her notes as some sort of one version of the math degree. And of course, we have the more sophisticated mathematics in the N lab, and we have some sort of translations into other languages, because that's also a small problem that, you know, it's for another day. But if you look at this one here, if you look at the France undergrad degree, you see that this is a resource that we found on the web without difficulties, but it is a way of making sure that the theorem prover Lean, which is very famous at the moment and is going places quite a bit, that the finding things into the code base of Lean using language. So and the reason it's called France UG is because the French have a description of everything that the person should learn in a mathematics degree, and the guys from Lean made a mapping from these words into their code base. So that's how it works. If you look at 0-1 law in MathGloss, you click on the link and it goes to, well, I'm sorry, now it goes to MathLib 4. That's when I took the picture, it went to MathLib 3, which is the mathematical library of the Lean theorem prover or proof assistant. So 0-1 law is over here, is any Kolmogorov 0-1 law, any event on the tail of a sigma algebra, blah, 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 blah. So the idea of MathGloss is that that there's loads of other resources on the web that should be put together to make mathematics more accessible. And how we're going to put them together is still up for grabs. How we're going to construct this knowledge graph of mathematics still up for grabs. There's problems with people who kind of want to keep their data private, like MathWorld, Wolfram Alpha, but there's lots of other things that are free and usable, like Wikidata. And the idea here is that these columns can be swapped, right? At some stage, we had France UG and the ProofNet project from CMU, which is again doing certain proofs in analysis, I think, if I remember correctly, but mapping from language to ProofNet, which is this other project. So the idea here is that different people can change their columns for whatever they think is useful for them. Okay, we are continuing all these 3 different small projects. with different people. I should have the names of everyone. I didn't. That's bad on me. But these projects are carrying on, and there are new projects coming up. But I think so I'm calling it continuing work, because the results so far are not brilliant. But with some judicious prompting, ChatGPT can find math terms and can do more than that. And we have been using it for doing inference over mathematics as well. But the difficulty is that ChatGPT, or actually GPT-4, much more, because lots of the things that they do are so good, so on point, when it gets wrong and it's kind of says to you that something with the most conviction, something that's completely fabricated, we are in trouble. And for mathematics, you cannot have that situation where things like that. So we need to measure the quality of the LLM results, and we are kind of wanting to do other stuff. We want to have other interactive theorem provers connected to something like MathGloss. We want to grow up MathGloss to much bigger. And this is all very topical. There's lots of people thinking along these lines, some friends, some people who we would like to work with. And we need funding for that. And we have a problem with funding for that, because some people think that this all has happened already, and it hasn't. And some people think that the industry is going to be doing it for us. I'm sorry, it's 3 minutes over, but I just want to finish on this line. When we submitted the project to NSF, one of the reviewers said something like, the industry will do that. And I personally don't see a reason why the industry would do any of that. I think we have to find other ways of getting it to happen, because it's not in the interest of industry to get people more able to do this kind of work. And with that, I'll stop. I'm sorry about the 4 minutes extra. Thank you very much.
Thanks very, very much for this extremely interesting talk.
Thank you, Agatha.
Yes,
Do we
thank you
have,
very much.
I think we have at least 4 questions, right?
Yes, I see them. Yes, so there's 2 questions regarding the recording and the resources and the presentation slide after the webinar. So regarding the recording, this has been live streamed on YouTube on the VCLA YouTube channel, and the recording will be available there. Wait, let me share the link in the chat. And about the slides, yeah, do you want to share the slides afterwards, Valeria, or?
Sure, with pleasure. I mean, that's the idea, you know. That's why I kind of I had the trouble to transform gigantic URLs into tiny ones so that they could fit in this slide. So yeah, no, it's for people to click on them and go in and check things more for themselves. Yeah.
Okay, so there is one question, namely, given all the ethical issues with large language models provided by the extant companies, so CO2 production, environmental degradation, stolen and unattributed training data, harms produced by their usage, do you think there is hope to train your own large language model on a more targeted data, say the archive plus Wikipedia, to avoid these ethical issues and get even better results?
I think there's always hope. You know, if there wasn't hope, we wouldn't be doing things, right? And of course, there are some people there are lots of other people who want to have open source, real open source large language models. And there's lots of work on much more competent people than me to try to reduce the amount of data that's required for things. And of course, there's enough, I mean, there's an awful lot of people who want to do science for the benefit of humanity. We are not the only ones saying that, right? There's lots of people who want that. The difficulty is kind of getting there as usual. So it's how we can coordinate smaller projects and put them together. That is the hard thing, I find. I think, I mean, I've been a little bit facetious and a bit mean to my friend linguists or computational linguists or NLP guys, because, you know, they do have an awful lot of things going for them. One of the things that they have going for them is the fact that they actually do want everything open, right? You know, if you need to read a paper in AI, in NLP, you find it because, you know, their association, professional association, has been much better than other professional associations. They have this ACL ontology. ACL stands for Association for Computational Linguistics, that actually has everything. So kind of, you know, there, the problem is not being able to or not being able to read things. There, the problem is, as the person who asked the question is saying, is the problem of money to run the data centers and kind of not be a monster like most of the guys that run data centers have been in terms of how they treat their employees and stuff like that. But so these are other completely different discussions that I don't think I'm so good at being able to provide information about. I think for our purposes, for the purposes of now restricting myself to mathematics, I think we should be able to put together the several different smaller projects and get something good. But I don't know exactly how yet. I'm working. Trying to talk to as many people as I possibly can about it.
Okay, then we have another question which says, could you please provide more information about the research about causality? You mentioned that this direction still needs some more work to be done. Would you like to share an example?
Oh, sure. Well, examples are always easier to do. I mean, the thing I'm thinking of is that causality is a very big phenomenon, right? You know, it goes from things like the grass is wet, so it must have rained before or something like that, to things like if I turn the switch on, like I did early on, I turn the light off or on. And one of the easy things one of the ways of tackling the problem of causality is the way that some of the guys following, what's his name? Judea Poe guys are doing with things like causal graphs and also causal inference trees, which is something that the guys from the AI Allen Institute for AI are doing. So some causality phenomena happens in language, and for this side of the causality phenomena, we can use some of the tools that we have already in this lots of research that has happened before on so-called NLI, natural language inference. And that is one of the things that we are trying to do, is to do natural language inference using mathematical texts. So that's as much as, you know, it's just, we are doing experiments at the moment. We haven't got results yet. So it's not written. So but But I think it's obvious that that if you do the mathematical trick of restricting your thing hard enough to small enough, saying you will find examples, we will find results, and the question is how good these results will be. So that's why it's very preliminary. And I mean, I hope the person who asked kind of know enough about causality to see where what I'm getting at, because if it's not let me put it in a different way. Some people are taught in mathematics in particular that some things like causality, we shouldn't even touch it because we don't have tools to deal with the problem. I disagree. I think, and people in AI also disagree, and they all kind of try different tools to deal with causality. And I'm saying that, we can use the tools from generative AI to do something. The difficulty is how good this something is going to be.
Great, thank you. I did not see any more questions in the question and answer. Are there people that want to, if you want to kind of just say your question, you can raise your hand and I can allow you to talk, and you can, just say it instead of type it.
Well, while people are thinking about that, I wanted to say one more thing, which is that I think the business of going back to the previous part of the conversation, the business of women in logic, it's kind of what I find important for us. The reason I wanted to say again that I thank you guys for starting this is that you can't really think about the problem of women in STEM occupations or in the world one day in every 365 days, right? You have to have much more than one thing like that, like what we've been doing before with Will. So I think, even if we make 6 online talks, and if we kind of carry on, again, curating and connecting the different people that are already thinking about these things, then we will be much stronger, right? So I discovered recently that there are 80 different women in X, where X is a bit of mathematics. I did not know that. I knew about women in machine learning and women in AI and women in logic, and in women in computability, who are friends of ours too. So, these guys I knew but, I discovered that there are many more of us, and not knowing them is part of our problem. We need to know that they exist and what they are doing, and try to use their tools for our stuff too, right? So.
Yes. Valeria, thanks really a lot for it. First of all, your inspiring talk, but also for all your initiatives that, yes, I see that they are really important.
Thank you. Thank you, Agatha.
We greet the audience and we give them the appointment to the next talk. We don't know yet the exact date, and we also don't know yet the speaker, but you will hear from us soon.
Yes.
Fantastic.
Absolutely.
Thank you so much. Oh, there's a hand now. 2 hands.
Oh, I don't.
Oh, it's just.
Yeah, they were very quick hands. They disappeared again. So maybe people try to do the clapping
these are
emoji.
people who are doing clapping their hand.
Yeah.
And
sure.
Andrea, thanks again for your great help.
Indeed.
Yeah.
Thanks, Andrea. It
You're
was
welcome.
very helpful.
I will now stop the recording and the
Yeah.
live stream. Yeah. Also, thanks from my side for your inspiring talk.
Thank you.
Valeria, maybe we should put the link to the talk on the Women in Logic webpage.
Yes.
And maybe also, if you want to share your slide, you could also do it there.
Right, will do. The thing is, I'm changing I have a friend who's helping me to change the Women in Logic website, because it's